Welcome back again, solving numerical problems. This time I'm starting a new series where I'll be explaining MCQs, multiple choice questions with 4 choices and which choice is correct. And in fact, each part of the solution will be explained to you also. Now let us go back straightway to the problem, the statement of the problem. A small sphere, look, this M is a small sphere, is having a charge Q, is hanging between two parallel plates. This is one plate, this is another plate, both are parallel, and this plate is positively charged and this plate is negatively charged, equally negatively charged. They can be unequally also negatively charged and positively charged. That is same thing as the sphere of mass M is hanging within a parallel plate capacitor. The length of the string from this point to this point is L, capital L. The time period of pendulum is T naught. Now when the plates are charged, before the plates were charged, the time period was T naught. Now the two plates are charged, right? Then the new time period, the time period of pendulum is T naught. When the parallel plates are charged, the time period changes to T. Before the plates were charged, the pendulum was just hanging, mass M, length L. And as you know in your school days, the time period of a pendulum is T is equal to 2 pi times L over G, square root of that. So, when the plate was not charged, the time period was T naught. It is given there. Now the two plates are charged. Now the time period is a T, which we don't know. And we need to find out the ratio of T, we have to find out T over T naught. Now what happens when it is inside the two plates, the length of course does not change. A length is constant. Let us see what will happen to the acceleration due to gravity, the net acceleration. Now you must have studied in your school days in electrostatics when there are two charges Q and Q separated by a distance r, the force between them was equal to 1 over 4 pi epsilon naught Q over r square. That was your Coulomb's law. I will explain. Now, who is experiencing this force? This capital Q is experiencing due to small q and the small q is experiencing due to capital Q. Means the ratio of Coulomb force is always 1:1. Now, then you must know what is electric field. Now, this Q charge is experiencing this force to the small charge Q. So 1 unit of positive charge will experience. How I come from here to here? By dividing this by capital Q. So I have to divide it here by capital Q. So I am left with 1 over 4 pi epsilon naught Q over r square. This is called the electric field. Symbol is E. This is nothing but force experienced by 1 unit of positive charge. Similarly, if you look at the other way, Q charge is also experiencing the same force due to capital Q. So 1 unit of positive charge will experience this over small q. So we are left with 1 by 4 pi epsilon naught Q over r square. Since this is the force experienced by 1 unit of positive charge, so this will also be called the electric field. So, what's the difference between these two? This is the electric field due to this charge at a distance r from it. This is the electric field due to this charge, capital Q, at a distance r from it. So the conclusion is electric field due to a single charge, point charge, is proportional to 1 over r square. Means if r increases, E decreases. That is one way of explaining electric field. Then there is another way. Suppose Q charge is experiencing F force due to some other charge. So 1 unit of positive charge will experience a force F over Q. Since this is the force experienced by 1 unit of positive charge, so this will also be called the electric field. Now cross multiplying, F is equal to QE, and any F, force, is mass into acceleration, that is equal to QE. So acceleration is equal to QE over M, right? So here lies the crux. So when this ball of mass M has a charge Q, positive Q, if nothing is mentioned here, means positive Q. So this will experience a force, this will experience an acceleration, QE over M, and that acceleration will be to which side? Since this is positively charged, this positive side, the field is to this way, the electric field is to this way. So this mass will experience an acceleration in addition to the acceleration due to gravity. It will experience another acceleration that is equal to QE over M. QE over M. So there are two accelerations. G is to this side, again QE over M is to this side. Both the vectors are in the same direction, so the net acceleration is equal to G plus QE over M, right? So the new time period, T will be equal to, using the same expression. Now the present time period will be 2 pi L over, now instead of G we have to write the net acceleration, that is equal to G plus QE over M. So this is one time period after both the plates are charged, and this was the time period before the plates were not charged. Now you divide. Now you divide T over T naught. You divide T over T naught. That is this over this. So 2 pi cancels. So you will have equal to L over G square root of that multiplied by this comes to the numerator, G plus QE by M over L square root of that. So you have square root of L here, square root of L here cancels. So you get 1 over square root of G, and here G plus QE over M square root of that. So if you simplify it here, you get G plus QE over M over G square root of that. Now that is G by G, that is 1 plus QE over M over G square root of that. Now that is equal to that's why, is that the way it is given? Yeah. So your answer is equal to, the choice C. Your choice C, right? You can take G common here. And right. So your answer is equal to your C. So that's all about. If you need a printed part of it, you can call me. Now the same thing I have explained here in a typed form. It will be convenient for you to write down. Let me once again explain it. Before it was charged, before the two plates were charged, the time period was T naught. That was equal to 2 pi. That was equal to T was equal to 2 pi L over G T naught. After the plates are charged due to the electric field, the acceleration will be equal to Q by M times E. And how this will be the acceleration in an electric field where there is a charged particle having charge Q and mass M, I just explained you here. So now the same object having mass M, charge Q, will be having two forces acting downward, mg plus qe. So if you take out m common, the remaining part is your acceleration. So due to this is your force, that is equal to m times g. So your now new acceleration becomes g plus qe over m. So the new time period using the same expression t is equal to 2 pi L over g square root of that. Now for g we have to replace it with g plus the extra acceleration, that is equal to QE over m. So this becomes the present time period. So if you divide, you get t over t naught is equal to this. So the choice C is equal to the correct choice, right? So thank you very much.